Imagine a small clay tablet, not much larger than today's textbook, displayed behind glass in a Berlin museum. It bears the catalog number VAT7847. For years following its unearthing from the remnants of ancient Mesopotamia, experts couldn't quite decipher its meaning. The inscriptions were straightforward, minute wedge-like marks etched into the clay around 1200 BCE. Yet the picture they created puzzled everyone. Archaeologists who unearthed it scratched their heads. Early cuneiform specialists who documented it remained baffled. Only when an expert versed in ancient tongues and contemporary astronomy scrutinized it did the truth emerge. This was no rough sketch or divine illustration of celestial deities. Instead, it portrayed a detailed layout of the solar system, planets circling a central star, with approximate sizes shown and positions aligning remarkably with our current understanding. It even included elements that, by rights, no one from 3,000 years back should have grasped. Tonight, we embark on an incredible journey. We'll trace clues from the fragile clay records of ancient Sumer right out to the fringes of our solar system, and further still. We'll explore the cosmic insights the ancients seem to possess, information that, in certain instances, modern science only verified in recent decades. We'll delve into particular tablets, writings, and cuneiform astronomical records, contrasting them with discoveries from our observatories and spacecraft. And we'll confront puzzles that today's academics struggle to explain away. This isn't idle conjecture. It's an examination of the actual content inscribed on those tablets and embedded in long-standing celestial lore, posing one straightforward query. How on earth did they figure it out? Let's begin with the basics. What grasp did the Sumerians have on the solar system's layout? And how does that stack up against Western scientific views over the ensuing millennia? For much of documented Western history, our cosmic framework was utterly mistaken, boldly, assuredly, and officially so. From Ptolemy in the 2nd century CE until Copernicus unveiled his groundbreaking theory in 1543, the prevailing view put Earth smack in the middle of it all. The sun, moon, 5 naked-eye planets, and fixed stars were thought to circle us. This went beyond mere theory. It was enshrined church dogma, upheld by inquisitions, and hailed as obvious fact for more than a millennium. Copernicus's suggestion that Earth revolves around the sun was branded heretical. When Galileo backed it up with telescope sightings in the early 1600s, he spent his final days confined to house arrest. The notion that our world wasn't the universe's hub rattled power bases so deeply that proponents faced outright persecution. But millennia before Copernicus, long before Galileo, and eons prior to Europe's first telescopes, Mesopotamian scribes were etching a sun-centered cosmic model into clay. The cylinder seal VA243, kept in Berlin's Vorderasiatisches Museum, stands out as a hot topic in unconventional history circles, and rightfully so. In the top left section of this modest Akkadian seal, from roughly 2500 BCE, there's what looks like a star encircled by 11 objects of different scales. If this symbolizes the sun and its planets, then this 4,500-year-old relic depicts a heliocentric arrangement with a planetary tally that astronomers didn't accept until 1781, when William Herschel spotted Uranus via telescope. Neptune's existence was verified in 1846, and Pluto, deemed a planet upon its 1930 detection, came even later. Of course, conventional Assyriology challenges this reading. Certain experts claim the core motif on VA243 is just a generic star emblem, not specifically the sun, and the encircling spots could stand for anything but planets. That's a valid scholarly stance worth pondering, yet it doesn't settle the matter entirely. After all, the seal is merely the flashiest element in a broader, more intricate enigma. The Sumerians produced a wealth of astronomical records, including the Mul-Apin tablets, assembled around 1000 BCE, yet drawing on observational records that experts trace back much earlier, forming one of antiquity's most detailed star catalogs. These inscriptions detail stars, star patterns, and the paths of planets with impressive accuracy. They document the heliacal risings of stars, their initial sightings right before dawn, a feat demanding consistent, prolonged watching. Yet it's within the wider collection of Sumerian and Akkadian astronomical writings that a truly intriguing pattern surfaces. The early Mesopotamians went beyond merely noting the 5 planets discernible without aid: Mercury, Venus, Mars, Jupiter, and Saturn, all detectable by any diligent watcher given time. Their overall cosmic model, outlined in various cuneiform documents, seems to incorporate additional objects invisible to casual sight. This prompts a comparison between contemporary astronomical discoveries and what might have been discernible in antiquity. Mercury, Venus, Mars, Jupiter, and Saturn shine brightly enough to spot telescopeless, shifting noticeably amid the starry backdrop. Hence the Greek term, quote, zero or wanderers. Societies with unclouded nights and dedicated stargazers could spot these 5 without issue. Uranus, Neptune, and Pluto, however, pose far greater challenges. Uranus, at an apparent magnitude of roughly 5.7, hovers at the limit of unaided visibility in ideal circumstances. Even if faintly perceived, distinguishing it from dim stars would require monitoring its motion for weeks or months, plus precise knowledge of its position. Neptune, with a magnitude of 7.8, remains utterly beyond naked eye detection. Binoculars at minimum are essential, and even then, star maps are needed to pick it out from countless faint specks. Thus, when cuneiform writings depict a universe extending past Saturn, it raises a real enigma. The Sumerians either possessed undiscovered viewing tools, improbable amid the thorough digs we've conducted, or drew from an obscure knowledge source, or perhaps stumbled into astoundingly accurate speculations. Each option leaves something wanting. The Enuma Elish, Babylon's foundational myth, narrates the solar system's genesis through symbolic tales. Experts have long analyzed its stellar elements. Here, Marduk, the deity linked to Jupiter, vanquishes the chaos goddess Tiamat, cleaving her form asunder. Half forms the sky, the other the ground. Driven by this clash, Tiamat's 11 monstrous companions meet defeat. Marduk then arranges the universe, positioning heavenly objects, fixing the calendar, and imposing celestial harmony. Viewed solely as legend, as conventional interpretations hold, it simply recounts how the Babylonian deity imposed structure on creation, but examined through an astronomical lens, specific elements stand out sharply. The division of a heavenly form, the birth of a rubble ring, the reshaping of orbital paths, these evoke unsettling parallels to today's ideas on the asteroid belt's origins and the solar system's primal turbulence. That belt lies squarely between Mars and Jupiter, exactly where 18th century stargazers, guided by the Titius-Bode law's numeric sequence, anticipated a world. Telescopes later unveiled not an intact planet, but a sprawling array of stony remnants, bits that failed to merge, or perhaps wreckage from a shattered one. Current science continues to explore the belt's beginnings, with the dominant theory attributing it to Jupiter's massive pull-halting planetary growth. Earlier ideas, however, proposed it as rubble from an obliterated planet, occasionally termed Phaeton in scholarly texts. Sumerian accounts portray this cosmic zone in ways that align more with the shattering theory than the failed formation one. The Enuma Elish doesn't merely halt Tiamat's coalescence, it portrays her as a pre-existing entity rent violently, her shards scattered throughout the heavens. One reading of these astral motifs holds that the ancient Mesopotamians, cloaked in mythic terms, recounted a cataclysmic breakup of a body between Mars and Jupiter, yielding the scattered remains we term the asteroid belt. Could this just be a fluke? Myths lend themselves to multiple interpretations, and it's risky to impose contemporary scientific ideas onto ancient writings. Still, the precision of this alignment deserves attention. The Sumerians didn't merely mention a void or blank area between Mars and Jupiter. They depicted a cataclysmic incident that left scattered fragments exactly there. That's an extraordinarily precise element to hit upon by chance. Now, consider the outer planets in more detail. The ancients recognized Jupiter and Saturn as luminous, leisurely travelers across the heavens, but their actual traits. That's where contemporary astronomy uncovers intriguing parallels. Jupiter stands as an enormous gas giant, mostly hydrogen and helium, with a chaotic atmosphere of raging tempests. Saturn boasts its stunning rings. Uranus leans over on its side, tumbling through its path like a rolling sphere. Neptune appears as a vivid blue planet, whipped by ferocious gales. When you examine consistent portrayals of these heavenly objects, translated with care, they feature traits that align surprisingly well with these realities. Accounts of a bluish-green world, references to a body encircled by bands, links to water or fluid elements. Such details hide within writings often brushed off as mere legend, yet their fit with observable facts provokes curiosity. In Sumerian cosmology, the Apsu represented the original freshwater sea predating all creation. In stellar terms, certain scholars tie the Apsu to the solar system's fringes, particularly the frozen objects past the gas giants. Today's astronomy verifies that the outer solar system teems with water ice. From satellites orbiting Jupiter and Saturn to Kuiper Belt items and further out, the European Space Agency's Herschel Space Observatory showed in 2011 that the isotopic makeup of water in Earth's seas resembles that of specific comets from those remote icy zones, implying our planet's water arrived from that far-off frozen expanse. The ancients viewed the cosmos's farthest edges as a domain of waters. Science now backs that view. In essence, the outer solar system forms a vast icy sea. Yet the most astonishing aspect of Sumerian celestial insight, the toughest to chalk up to mere luck or intuition, is their grasp of the equinox's precession. To grasp its importance, let's clarify what precession entails. Earth rotates on its axis every 24 hours, creating our days and nights. That axis isn't straight up compared to the plane of our orbit around the sun. It leans at roughly 23.4 degrees. Most importantly, this axis wavers gradually, akin to a top losing speed and starting to tip. Over about 25,772 years, this motion sketches a circle against the sky. One full loop takes nearly 26,000 years for the axis to realign. This motion carries tangible effects. The spot where the sun meets the celestial equator during the spring equinox, the vernal equinox, gradually drifts relative to the zodiac's stars. Currently, it falls in Pisces, a position held for about 2,000 years. Prior to that, it lay in Aries, and before Aries in Taurus. Each transition spans roughly 2,160 years. Soon enough, it will enter Aquarius, inspiring the term, quote, one. What elevates this in our narrative is the effort required to spot precession. Detecting it demands accurate stellar tracking and cross-referencing over countless generations. The movement crawls at about 1 degree per 72 years. Over a typical lifespan, the equinox shifts by just a degree or so amid the stars, capturing the entire 25,772-year cycle. Calls for unbroken meticulous records across thousands of years, or knowledge passed down from an informed source. In the West, precession gets attributed to the Greek Hipparchus, who noted it circa 127 BC by matching his sightings with prior ones. His rate of 1 degree per century was decent, but rough. The finer estimate of 1 degree every 72 years demands even extended observational spans. Remarkably, though, 72 features in Sumerian and Babylonian numerical astronomy. The Sumerians employed a base 60 system, the sexagesimal one, explaining our 60-minute hours and 360-degree circles. That 360 itself ties into precession. If you take the complete precessional cycle of about 25,920 years and divide it by 360, the result is 72. Then, multiplying 72 by 5 yields 360, while 72 times 30, the span of degrees in a single zodiac sign, produces 2,160, roughly the length of one astrological era. Such figures crop up time and again in old mythological and celestial writings. This pattern extends beyond Sumer and Babylon to various ancient societies, hinting at a common foundation of wisdom. For instance, the Norse tale of Valhalla mentions 540 gates, each broad enough for 800 fighters to pass through at once. That adds up to 540 times 800, or 432,000, a key precessional figure. Dividing 432,000 by 60 gives 7,200, and another division by 60 results in 120. All these tie back to multiples of the precession constant. Sumerian royal chronicles attribute a combined rule of 432,000 years to the antediluvian rulers before the Great Flood. In Hindu lore, the Kali Yuga, the briefest of the 4 cosmic eras, spans 432,000 years, and a full Mahayuga, including all 4, stretches to 4,320,000 years. The fact that these exact figures echo across distant lands and tongues is either a staggering fluke or proof of an ancient, unified astronomical heritage. This heritage wove precessional insights into legends, buildings, sacred practices, and even their basic math structures. Scholars Giorgio de Santillana and Hertha von de Chend esteem figures. With one teaching history of science at MIT and the other at the University of Frankfurt, released a pivotal 1969 book titled Hamlet's Mill. There, they meticulously traced precessional codes in global myths. Their key insight: a prehistoric stargazing legacy predating known societies had infused precession awareness into narratives passed down through generations and continents. The academic world has viewed Hamlet's Mill with mixed feelings. Some hail it as genius, others call it speculative excess. Yet, no one has debunked the numerical alignments in the sources. Those figures exist plainly. Precessional markers in societies that, per standard archaeology, lacked the means to discover them. For the Sumerians in particular, signs of precessional expertise surpass mere numerical echoes. Their zodiac arrangement follows precessional logic. The idea of splitting the ecliptic, the sun's yearly sky path, into 12 uniform 30-degree parts was a Sumerian breakthrough. This setup, which birthed the 12 zodiac signs we use in modern astrology, essentially forms a precession-based grid. It tracks the vernal equinox position over time, a pursuit that only makes sense when monitoring precession. The Sumerians cataloged the ME as core edicts shaping society. These ranged from rulership and harmony to scribal arts. Yet certain ME focus on astronomy, outlining star paths, seasonal rhythms, and links between sky events and ground happenings. Specific astronomical ME allude to vast periods, grand years, and star-defined ages, phrasing that mirrors deep precession comprehension. The Babylonians, building on and advancing Sumerian lore, compiled detailed sky logs of celestial sightings with impressive accuracy. Surviving examples cover the 7th century BCE through the 1st century CE, packed with countless notes on planet locations, solar eclipses, and star events. Today's experts confirm these entries as highly reliable. Still, Babylonian precision evolved gradually, rooted in Sumerian groundwork from earlier times. Such bases point to a legacy of meticulous watching predating the extant documents by ages. How ancient exactly? That's the puzzle with no firm solution. Sumerian culture arose circa 4,500 BCE in southern Mesopotamia, inventing script by 3,500 BCE. However, the star wisdom in their initial writings implies accumulated observations over centuries, if not millennia. Grasping planetary orbits, eclipse patterns, and precession shifts demands more than one era's effort. It requires stacked generations of precise logging, handed from mentor to apprentice, from writer to writer, across lineages. And the Sumerians themselves claim that's not the origin. The Sumerians didn't describe gaining this wisdom bit by bit via steady experimentation. Instead, they insisted it came directly from entities known as the Anunnaki, particularly through a key figure named Enki. Here's where the narrative grows truly divisive, demanding we carefully separate the original writings from the interpretations others have imposed on them. Still, the documents themselves merit close scrutiny, as the Sumerians' accounts of their knowledge's origins stand out as one of the most captivating elements in their whole body of literature. Enki, in their language, translates roughly to quote 2 or quote 3, yet his realm went far beyond the soil underfoot. He ruled over the Abzu, the ancient underground sea of sweet water. As the patron of intellect, sorcery, skilled labor, and every kind of practical expertise, he was the god the Sumerians honored for bestowing on humankind the essentials of urban life. Within the divine order, Enki held a special rank, among the mightiest deities, offspring of Anu the sky god, and part of the highest assembly of immortals. Unlike Enlil, the harsh god of storms who governed with iron will and occasional harshness, Enki came across as shrewd, kind-hearted, and eager to aid people despite resistance from fellow gods. In the tale of the Great Flood, Enki secretly advises Ziusudra to construct a vessel going against the heavenly body's choice to wipe out mankind. Myths of human beginnings show Enki shaping the method for our creation. Legends of societal beginnings depict him sharing the me, those holy edicts and insights, with various human settlements. These me warrant deeper focus. They're a hallmark of Sumerian philosophy without a direct parallel today. Scholars render them as godly commands, societal standards, universal truths, or blueprints for advanced society. The term me also implies core nature or existence, evoking something essential to reality's workings. In lore, the me appear tangible, like items that can be grasped, transported, safeguarded, gifted, or pilfered. The renowned epic of Inanna and Enki portrays the goddess heading to Enki's home in Eridu, where, blending allure and deceit, she coaxes the me from him amid his drunken state. She then piles them onto her celestial barge and sails them to her home in Uruk. The catalog of me she acquires is striking. It covers regal authority, the royal seat, the diadem, the staff, purely governmental ideas. There are skills like heroism, dominance, and cunning, innate human traits. Religious elements include the high priestess, temple aids, and holy enclosures. Practical trades feature the blacksmith's art, the tanner's work, construction techniques, and weaving baskets, vital crafts. Yet amid these, certain entries hint at deeper layers beyond mere customs. Some touch on melody and specific tools with their harmonies. Others cover scripting and documentation. A few address timing and calendars. And, vitally, some connect skywatching. Were the mere allegories, just fanciful tales? They'd intrigue, sure, but not astonish. Many societies spin yarns of deities imparting civilized skills to mortals. What sets the Sumerian inventories apart is their detail, the methodical grouping and listing of expertise with catalog-like accuracy, implying far more. They feel less like fables and more like a directory, an outline for a vast repository of specialized lore that the Sumerians held as delivered from beyond human origins. When it comes to celestial expertise, Enki's tie to water calls for extra notice. The Abzu, his watery abode, was imagined as an immense hidden reservoir of pure liquid. Today's earth science backs this up. A 2014 paper in Nature Geoscience calculated that groundwater in the top 2 kilometers of the planet's shell totals about 22.6 million cubic kilometers, dwarfing all above-ground freshwater sources. The Sumerians grasped the reality of this buried aquatic world, though they cloaked it in myth rather than data. Enki's watery links, however, reach cosmic heights too. In star lore, he links to Aquarius, our water carrier sign. His shrines aligned with star paths, ceremonies synced to heavenly happenings. The waters he oversaw didn't limit to subsurface flows or stream currents. Broadly speaking, this encompassed the cosmic waters, the fundamental essence from which the entire universe emerged. Contemporary cosmology has uncovered discoveries that, mere decades back, would have come across as outright fantasy. Water permeates every corner of the cosmos. Scientists have identified enormous deposits of water vapor within clouds drifting between stars, in the atmospheres surrounding distant worlds, amid Saturn's rings, atop Mars's polar ice formations, spewing from the geysers on Saturn's satellite Enceladus, and lurking in the buried ocean beneath the icy crust of Jupiter's moon Europa. Before its retirement, NASA's SOFIA Observatory verified the existence of water molecules across the illuminated face of the moon. Back in 2011, researchers spotted a quasar known as APM 08279 plus 5255, enveloped in a vast water vapor nebula holding 140 trillion times the volume of water found in Earth's oceans altogether. This stood as the biggest such cache ever found, located some 12 billion light-years distant, offering a glimpse into the universe at just 1.6 billion years of age. As it happens, water proves no scarce earthbound element. Instead, it ranks among the universe's most plentiful compounds. The Sumerians, via their tales of Enki and the Abzu, portrayed a reality defined at its core by water. In essence, they grasped a truth on a vast scale that they had no apparent means to comprehend. Yet to sharpen our focus, let's delve deeper into their precise astronomical insights, for the assertions about Sumerian expertise gain even greater weight through close scrutiny. The Sumerians monitored what they termed the MUL, a word denoting stars, star groups, or heavenly objects based on the situation. Their catalogs of stars went beyond merely noting the brightest lights. They structured the whole observable heavens into an orderly schema, divided into 3 bands: the root of Anu, hugging the celestial equator, the root of Enlil, arching through the northern heavens, and the root of Ea, another title for Enki, stretching across the southern skies. They allocated stars and patterns to these bands according to declination, or their angular offset from the celestial equator. Such a tri-band arrangement marks a refined celestial model. It demands grasp of the celestial equator as an imagined projection of our planet's own onto the vault above. It calls for methodical tracking of stars' ascents and descents against that line, and it hinges on a calculative system for segmenting the skies into regions, a system the Sumerians indeed possessed. The MUL.APIN tablets, serving as our fullest preserved archive of Mesopotamian sky lore, enumerate scores of stars and configurations sorted along these three bands. Today's stargazers have matched nearly all the named stars, validating the authenticity and precision of those ancient sightings. Beyond that, the tablets detail the heliacal risings and settings of prominent stars, data leveraged in archaeoastronomy to pinpoint the timings of the records themselves. When experts apply this approach, intriguing patterns emerge. Certain sky alignments noted in the MUL.APIN tablets align not with around 1000 BCE, the era of their assembly, but with far older configurations, possibly reaching into the 3rd or even 4th millennium BCE. This implies that the Babylonian compilers of the MUL.APIN drew on empirical records handed down from Sumerian times or before. The Sumerians further charted planetary cycles with striking precision. They grasped the synodic period of Venus, the interval for it to realign in the sky relative to the sun from our earthly vantage. Their estimates neared the current value of 583.9 days. The Venus tablet of Amisaduqa from the 17th century BCE and spanning 21 years of notes, logs meticulous accounts of Venus's showings and vanishings. Modern experts have drawn on these to assess Babylonian sighting reliability and to refine timelines for the ancient Near East. Tracking Venus's cycle, however, is one feat. A diligent skywatcher over several years might achieve that. Far more impressive stands the Sumerian calculative model for celestial wanderers' paths. They devised prediction techniques for planetary spots that, though distinct from today's formulas, yielded impressively reliable outcomes. The famed System A and System B of Babylonian numerical astronomy, employing stepwise and linear oscillating functions to model planetary paths, reflected a mathematical depth unmatched in Europe before the Renaissance. Moreover, these techniques extended past the observable planets. Their core arithmetic structures could tackle far knottier challenges than merely forecasting Mars's position come next month. Such methods outlined a broader strategy for studying heavenly bodies, pointing to insights into orbital paths that go well beyond what anyone could glean from unaided eyesight. That's an essential insight. Spotting planetary movements is one thing. Comprehending the reasons behind them is quite another. For instance, one might watch Mars tracing its path across the constellations without realizing it's circling the Sun on a trajectory distinct from ours. Similarly, you could see Venus hugging the Sun's position without knowing its orbit lies within Earth's. This gap between seeing and knowing is key, since the Sumerians' mathematical handling of planetary paths indicates they lean toward true comprehension, not just passive watching. To illustrate, take how the Sumerians recognized that the 5 planets visible to the eye weren't uniform. They separated the inner ones, Mercury and Venus, which linger near the Sun, from the outer ones, Mars, Jupiter, and Saturn, that roam freely across the sky's belt. That separation aligns with grasping how certain planets swing nearer to the Sun than Earth does, while others loop farther out. It clashes, though, with the idea that all things circle Earth, as the later Ptolemaic model proposed. The Sumerian word for planet Lu.bad gets rendered by some experts as wandering sheep, with every planet assigned a unique label alongside meticulous sighting logs. In certain Babylonian records, Jupiter went by Nibiru, a word evoking a crossing or ferry spot, stirring up huge debates in today's fringe history debates. We'll tackle that uproar head-on soon enough, but astronomically, the point stands that the Sumerians monitored Jupiter closely, clocking its 12-year cycle and its commanding role among the planets. And they had good reason. As the solar system's biggest world, Jupiter outweighs every other planet put together. Its pull warps asteroid paths, snags passing comets, and likely influenced how the inner planets took shape and changed over time. By dubbing Jupiter the planetary ruler and devoting extra scrutiny to it, the Sumerians tapped into a cosmic truth that today's scientists have only grasped in the past 100 years. Now shift focus to a group that initially appears worlds apart from Mesopotamian antiquity, yet piles on even more intrigue to the riddle of early star wisdom, the Dogon of Mali in West Africa. Nestled in the Bandiagara Escarpment, a sprawling 150-kilometer sandstone ridge slicing through Mali's dry heartland, the Dogon farm millet and onions amid the crags, herd animals, and cluster in cliffside villages. Their building style stands out, featuring lofty silos topped with pointed thatch roofs and sacred sites known as Tonom, where leaders gather for village matters. Back in the 1930s, French researchers Marcel Griol and Germain Dieterlen launched in-depth studies with the Dogon. For some 20 years, they cataloged the people's spiritual views, ceremonies, and views of the cosmos. Their findings stunned everyone and still spark fierce arguments in anthropology and archaeoastronomy. As Griol and Dieterlen described it, Dogon elders held precise details on Sirius, the sky's most brilliant star. That's not so odd on its own. Sirius catches the eye, and plenty of societies weave tales around it. But the depth of what these elders revealed, that's the jaw-dropper. They told Griol that Sirius isn't solo but paired with a partner, that this sidekick, what we label Sirius B, circles the primary one every roughly 50 years, that it's minuscule, super-packed, and incredibly weighty. They named it Potolo, drawing from the tiniest seed they knew, the Digitaria grain, to highlight its wee scale. They portrayed it as the universe's densest load, insisting no collection of Earth creatures could budge it. What makes this so striking? Sirius B qualifies as a white dwarf, the shrunken core of a burned-out star. It packs sun-like mass into something Earth-sized. Just a spoonful of its stuff would tip the scales at 5 to 10 tons here on our planet. So dim, it evaded telescopic detection until 1862, when U.S. optics craftsman Alvin Graham Clark caught sight of it using an 18.5-inch refractor, then among the globe's mightiest scopes. Mathematicians like Friedrich Bessel had forecasted its presence in 1844, drawing from irregularities in Sirius A's movement across the sky, yet spotting it demanded advanced telescopes to bring it into view. Sirius B completes its orbit around Sirius A every 50.09 years, a duration that closely mirrors the one outlined in Dogon lore. This celestial body truly is minuscule, incredibly compact, and immensely massive, aligning precisely with what the Dogon have long asserted. How did an agrarian society from West Africa, lacking any telescopes or formalized star charts like those in the West, gain insight into a star that eluded European stargazers until they deployed intricate calculations and state-of-the-art lenses? The Dogon accounts also mention a potential third element in the Sirius setup, dubbed Eme-Ya, or the sun for women. They portrayed it as bigger and less dense than Potolo, tracing a broader loop around Sirius A. Back in the 1990s, researchers Daniel Benest and J.L. Duvant from France released findings indicating that such a third mass could orbit there due to gravitational dynamics, even if no telescope has ever pinned it down for sure. If Ya turns out real, the Dogon would have anticipated a feature that contemporary science has merely speculated about. Critics counter with notions of external influence for the Dogon star lore. The leading theory points to cross-cultural diffusion, positing that the Dogon picked up details on Sirius B from European explorers, clergy, or wanderers prior to Marcel Griaul's investigations. Astronomer Carl Sagan floated this idea, observing how buzz about Sirius B spread through scientific networks post-1862 discovery, while outsiders had frequented Dogon lands for years before Griaul's tenure. That's a fair point worth examining thoroughly. Certain ethnographers wonder if Griaul himself might have misconstrued or subtly influenced the tales he gathered. Interactions between locals and investigators often blur lines in such studies. Perhaps Dogon storytellers, keen to impress an engaged outsider, wove in scraps from elsewhere to amplify their narratives. Yet the diffusion argument has its flaws as well. For starters, the Dogon's grasp of Sirius forms part of a broader cosmic tapestry, encompassing myths of origins, the makeup of substances, and the layout of the heavens, all conveyed through their symbolic rituals and tied to farming cycles and ceremonies. You don't absorb that depth from a fleeting chat with a traveler. It's deeply interlaced with their core beliefs, hinting at ancient roots over fresh imports. Moreover, certain Dogon star details diverge from what Western science understood in the early 1900s. The notion of Ya exceeds anything a European could impart then, since Sirius C remained untheorized in the West for generations afterward. Should the Dogon just echo outsider info, they've somehow enhanced it with elements that later proved spot on. Additionally, their heritage features precise observations of other sky features, like Saturn's bands and Jupiter's satellites, that fit into their mythic framework, implying organized insight over scattered trivia from foreigners. The Dogon enigma lingers without a tidy answer. Ancient origins and borrowed knowledge each leave gaps in accounting for the full picture. What stands clear is that the Dogon professed a heritage of sky wisdom encompassing confirmed truths about unseen stars, details matching today's discoveries, and wove them into a holistic view of existence, not as standalone trivia. Beyond that, the Dogon origin story merits note for another layer. It depicts the cosmos emerging from one minuscule seed, the Po, the tiniest kernel, that unfurled in a twisting swirl, birthing substance and energy along the way. Far from arbitrary symbolism, this evokes in poetic terms a process akin to the Big Bang fused with galactic spirals, reality bursting from a pinpoint singularity, swelling to forge coiling forms. Science only reached this conception in the 1900s via Edwin Hubble's proof of cosmic expansion and spiral galaxy patterns. Caution is key here. Myths bend to interpretation if you push. Still, the Dogon imagery rings specific, an all-encompassing speck igniting, a surge of generative power radiating out. It forms a spiral arrangement in the emerging framework. These aren't vague symbols of origins. Instead, they align closely with what we observe in cosmic structures, almost too precisely for comfort. Now let's examine the Sumerian grasp of eclipses, which highlights the impressive extent of their hands-on astronomical skills. Forecasting eclipses demands knowledge of the sun, moon, and Earth's shadow geometry. It calls for awareness of the moon's orbital cycle, its tilt relative to the ecliptic, and the lunar nodes, the spots where the moon's path intersects the plane of Earth's orbit around the sun. Babylonian stargazers, drawing from Sumerian roots, refine the Saros cycle, roughly 18 years, 11 days, and 8 hours long, when the sun, Earth, and Moon realign in nearly identical positions, yielding recurring eclipse patterns. The Saros cycle remains a tool in today's eclipse calculations. It derives from a Babylonian word, and the foundational data came from generations of meticulous logging that started in Sumerian times. Spotting the Saros cycle doesn't happen by chance, though. It takes monitoring eclipses across hundreds of years, since the rhythm isn't clear in brief spans. Eclipses in each Saros series shift locations on Earth. Thus, compiling the sequence needs data from various sites or extended records from one spot to connect the dots. That Mesopotamian skywatchers pulled this off points to a legacy of observation marked by remarkable persistence and rigor. Cuneiform astronomical tablets include so-called goal-year texts, charts that let astronomers forecast planetary events by linking to established cycles. Mercury's was 46 years, Venus 8 years, Mars 79 years, Jupiter 71 years plus 6, Saturn 59 years. These intervals mark when a planet reappears near its prior spot against the sun and fixed stars. They're spot on. Contemporary astronomy tweaks these core intervals just a bit. The persistent puzzle isn't if the Sumerians and their Babylonian heirs excelled at astronomy. They clearly did. It's whether their advanced techniques can be chalked up solely to direct viewing within the time they had, or if they built on a profound pre-existing store of wisdom when inscribing the earliest clay tablets. Before circling back to precession, here's one final clue. The Sumerians portrayed the moon in ways hinting at insights deeper than basic watching. They recognized it glows from sunlight bounced off its surface. That may sound straightforward now, but it eluded many early societies. The Greeks argued over it for ages. Anaxagoras nailed reflected light as moonlight's origin circa 450 BCE and got banished from Athens for the bold claim. Yet the Sumerians seemed to grasp this well beforehand. They also charted the lunar rhythm with remarkable accuracy. Their calendar blended lunar and solar elements, inserting extra months to sync the moon's 29.5-day phases with the 365.25-day solar circuit. Handling that sync-up demands grasping the link between those cycles, and the Sumerians devised math for it that proves strikingly precise. Their accounts of lunar phases use wording implying orbital dynamics. They depict the moon gaining its luminous halo from the sun, waxing as it reaches opposition and fading on the return. That's an outline of the phases embedding the right geometric model. The moon shines full when opposite the sun from our view and dims when it doesn't. Obvious looking back, sure, but it took a mental shift that plenty of old civilizations skipped. Now, onto a precise link tying Sumerian star lore straight to their myths. Inseparable by nature, the tablets of destiny. In Sumerian, they're the Dub-Nam Tar-Ra, literally tablets of fate's decrees. In lore, they're no mere emblems of might. They're tangible items granting their possessor command over cosmic order. These tablets feature in multiple Sumerian and Akkadian tales. In the Anzu myth, a minor god snatches them from Enlil, sparking turmoil framed in stark astronomical chaos. Heavenly decrees jumbled, celestial mechanisms faltered, stars strayed from their paths. This goes beyond mere upheaval or disarray. This is portrayed as a breakdown in the mechanics of the heavens. Once those tablets vanish, the regular paths of the sky fall into disarray. Consider the deeper meaning here. The Sumerians viewed the predictable orbits of stars and planets not as an automatic, ongoing natural event, but as a system demanding constant upkeep via inscribed data. Essentially, the tablets of destiny served as the universe's core software. Yank them out, and everything glitches. Hand them back, and harmony resumes. Such a perspective on universal structure feels strikingly advanced. It goes beyond the basic image of deities shoving celestial objects across the firmament. Instead, it posits the cosmos as driven by data, by programmed directives that dictate orbital patterns, seasonal shifts, and the very progression of time. Peel back the mythic veneer, and what remains echoes modern physics in uncanny ways. A reality ruled by mathematical principles, fixed constants, and formulas shaping the dynamics of particles and forces, all rooted in the informational blueprint of existence itself. The texts claim the tablets held the me, those cosmic decrees we explored earlier, spanning realms from royal authority to artisanal skills. Yet the celestial me stand out. They encompass interpretations like stellar wisdom, calendrical expertise, holy metrics, and godly numeration. These form the exact toolkit essential for sophisticated stargazing, observational star lore, cycle tracking chronology, geometric standards for calculations, and arithmetic techniques enabling forecasts of heavenly events. Enki stands at the heart of this framework, offering key insights. He wasn't merely a holder of the me, he structured them. He sorted them into categories. He chose what to share and what to withhold. In the tale of Inanna and Enki, after Inanna outsmarts him into surrendering the me, Enki launches a frantic recovery effort, dispatching successive bands of otherworldly emissaries to recover his lost gifts. The intensity of his chase implies the me transcended mere icons. They embodied tangible operational wisdom, and their forfeiture equated to forfeiting dominion over that wisdom. Within the Eridu Genesis, among the most ancient Sumerian origin stories, Enki founds the initial urban centers and allocates the me to each. Specific roles go to particular places, one hub for sovereignty, another for skilled trades, yet another for sacred rites. This paints a picture of targeted expertise being intentionally divided and delegated to distinct sites, resembling a networked system for managing and disseminating knowledge. Eridu, Enki's own domain, was deemed by the Sumerians the planet's inaugural city. Strikingly, digs back this up. Located at modern Tel Abu Shahin in southern Iraq, Eridu reveals unbroken settlement, reaching to around 5,400 BCE, positioning it among Mesopotamia's earliest known settlements. Its foundational layers feature a modest shrine that expanded through repeated reconstructions, evolving into a major Sumerian sacred precinct. Deepest down at Eridu, excavators uncovered an oddity. Heaps of fish remains clustered near the primordial temple. Scholars see this as proof that initial ceremonies there centered on fish sacrifices, tying straight into Enki's lore. Enki linked to the Abzu, the subterranean sweet waters, and to piscine and watery beings. Sumerian lore of the Abgalu, the seven wise ones who delivered culture to humankind, depicts them as part fish, part person hybrids. They rose from the waves, imparted society's building blocks to people, then sank back into the abyss. The Greek chronicler Berossus, composing circa 300 BCE yet relying on ancient Babylonian records, detailed one such figure. He named him Oannes, likely a Hellenized version of the Sumerian Adapa, or Akkadian Uana, chief among the seven Abgalu. Per Berossus, Oannes surfaced from the ocean to instruct mortals in script, knowledge fields, urban planning, temple erection, legal systems, geometric principles, farming techniques, and seed categorization. In short, civilization's bedrock innovations. Berossus stresses that prior to Oannes, people existed in animal-like savagery, devoid of structure or insight. His teachings transformed it all, And vitally, Berossus adds that from Oan's era onward, no new discoveries emerged. Later human advancements merely elaborated on that primal endowment. That's an extraordinary assertion. Here, a 3rd century BCE Babylonian cleric asserts that the bedrock of society didn't evolve gradually through human effort. This knowledge came ready-made, brought by an otherworldly entity emerging from the sea, with all later advancements merely building upon that initial endowment. Certain experts view the Akalu lore as a symbolic recollection of an encounter with a superior maritime society that imparted wisdom to the nascent Mesopotamians. In contrast, others regard it purely as a mythic origin story, offering a rationale for existence itself instead of a factual chronicle of origins. Yet the enduring nature of this lore, spanning various documents and eras, the precise details of the expertise credited to these entities, and its ties to findings at Eridu archaeological sites point to far more than mere fanciful storytelling. Shifting back to the celestial details, let's explore the Sumerians' insights into individual planets, as that's where the enigma intensifies. While we've covered the overall solar system framework, now think about their portrayals of particular celestial objects. The world we know as Mars went by Mulbaba among the Sumerians, or Salatanu in later Akkadian terms. In legends, it linked to Nergal, deity of the netherworld and warfare. They observed its distinctive crimson shade and tied it to bloodshed and strife, a link that appears separately in diverse societies. The Romans dubbed it, after their war deity, Mars. Egyptians referred to it simply as the Red One. Chinese linked it to flames and the hot season, but Sumerian accounts extend past mere hue. Some inscriptions depict Mars with hints of its terrain features, alluding to powdery dust, dry barrenness, and a terrain like ruddy soil. Contemporary studies of Mars verify it as a parched, dusty realm with iron oxide, lending its signature red tint. The rust-like coating on its crust accounts for that color, visible even as a ruddy circle via telescope, with details verified first by Mariner 4's 1965 pass and later probes. Might the Sumerians have inferred Mars's landscape just from observing its redness? It's conceivable. Scarlet evokes iron-rich dust, and a creative mind could envision desolation. Still, the reliability of these portrayals, alongside the wider trend of spot-on celestial data, renders the parallel striking. Saturn, termed Mul Udu Idim by the Sumerians, connected to Nanuta and eventually Ninib. A few atypical passages portray Saturn in manners that some analysts take as allusions to encircling bands. The wording remains open to interpretation. Phrases implying enclosure or encirclement get rendered by enthusiasts as ring references, whereas conventional experts see them as nods to the planet's deliberate, unhurried path across the firmament. Confirming Saturn's bands demanded Galileo's 1610 telescopic view, though he couldn't clarify the sight, likening it to appendage-like ears. Only Christian Huygens, using an improved instrument in 1655, properly discerned the rings. For the Sumerians to recognize such features would demand advanced sighting tools, yet no records or origins indicate access to them. Jupiter, the solar system's colossal presence, drew meticulous observation from Mesopotamian stargazers. They accurately grasped its 12-year path around the zodiac, the duration for one full loop. This dozen-year rhythm influenced the 12-animal cycle in the Chinese zodiac, hinting at the spread of star lore via ancient commerce paths linking Mesopotamia to Eastern Asia. What stands out most in the Mesopotamian view of Jupiter, however, is their emphasis on its significance. Far from an ordinary wanderer, they portrayed it as the shaper of destinies, the arranger of the cosmos, the force that reigns in the rest. From today's astrophysical lens, this aligns strikingly with Jupiter's actual function. With a mass 318 times Earth's, its gravitational pull permeates the entire system. It snares or reroutes comets and asteroids that might otherwise bombard closer worlds. A number of experts in planetary dynamics contend that absent Jupiter's safeguarding pull, our planet would face devastating collisions much more often, potentially dooming advanced life forms. Jupiter further aids in steadying the orbits of fellow planets, preserving the solar system's balanced configuration across eons. Labeling Jupiter as the celestial organizer strikes a chord with modern views. Indeed, it structures the heavens, its pull second only to the sun's in molding the system's architecture. Scientists verified this tangible reality during the 20th century via intricate simulations of gravitational forces. How could an ancient society, devoid of telescopes or advanced computational tools in astrophysics, reach such an identical insight? Next, we'll explore one of the most intricate and reliable elements of Sumerian astronomical insight, their grasp of the numerical connections among planetary paths. The Sumerians, along with their Babylonian heirs, crafted what experts term planetary theory, mathematical frameworks designed to forecast planetary locations in the night sky for dates far ahead. The most advanced iterations of these frameworks emerged during the Seleucid era, spanning roughly the 3rd to 1st centuries BCE, though the foundational observations date back centuries earlier. Modern researchers have labeled these as System A and System B, which employ distinct mathematical approaches to tackle the identical challenge of charting a planet's position across time. System A relies on a step function, assuming the planet's velocity remains steady within specific zodiac segments and shifts sharply at their edges. System B, by contrast, applies a linear zigzag function, where the planet's speed rises steadily to a peak before falling evenly to a low point, creating a jagged sawtooth effect. Each method delivers precise forecasts, and both demand vast amounts of empirical data for fine-tuning. What's truly astonishing is how these mathematical strategies foreshadowed approaches that Western mathematics wouldn't codify for hundreds of years. The zigzag of System B essentially mirrors a piecewise linear stand-in for a fluid curve, a method central to today's numerical techniques in computational fields. Meanwhile, System A's step function serves as a segmented mimic of ongoing change, a core idea in the study of numerical approximations. In 2016, Mathieu Ossendriver from Humboldt University in Berlin released a pioneering study in science showing that Babylonian stargazers employed a type of geometric computation, namely calculating the space beneath a curve, to monitor Jupiter's trajectory. Experts had long credited this approach to medieval Europe, some 1,400 years in the future. Yet the Babylonians wielded something akin to integral calculus, the branch of math dealing with regions under curves, to address celestial puzzles nearly 2,000 years prior to Newton and Leibniz codifying it. Researchers confirm this through meticulous examination of 4 cuneiform tablets, and the discovery has gained broad endorsement in mathematical and astronomical circles. Far from mere note-takers of the skies, the Babylonians forged advanced mathematical instruments for scrutinizing and anticipating phenomena. Instruments that experts once believed arose only in far more recent phases of human thought. This prompts us once more to wonder, what was the origin of this mathematical lineage? The Babylonians drew it directly from the Sumerians, and the Sumerians, by their own records, received it from the Anuna, from Enki. from entities arriving from distant realms who bestowed upon humankind the instruments of wisdom. Now, consider another facet of Sumerian celestial understanding that unexpectedly aligns with contemporary findings. The Sumerians portrayed water not merely as a terrestrial material, but as a foundational cosmic force. As we've seen, the Abzu, Enki's realm, symbolize the original waters, yet they also link the cosmos's distant expanses to water. The deity Tiamat, whose defeat in the Enuma Elish forges the sky and ground, embodies saline waters, the immense universal sea. In 2015, researchers analyzing Cassini probe data established that Enceladus, a moon of Saturn, possesses a worldwide underground sea of liquid water, sustained by tidal friction from Saturn's pull. That same year, NASA's New Horizons probe uncovered evidence suggesting Pluto, in the chilly fringes of the solar system, conceals a subsurface layer of water ice blended with ammonia. Since the 1990s Galileo mission, scientists have recognized that Europa, Jupiter's icy satellite, hides an enormous liquid water reservoir under its frost, holding more volume than Earth's entire seas. The solar system's outer zones teem with water in every form imaginable. As one ventures farther from the sun, water proliferates, locked in ice across moon and dwarf planet exteriors, flowing beneath frozen shells, drifting as vapor in sparse airs. The Kuiper Belt, that enormous band of icy objects past Neptune, functions like a vast, iced-over sea encircling the sun. The Sumerians envisioned the universe springing from water, encircled by it, inherently fluid in nature. They were spot on. The cosmos brims with immense quantities of water. Water ice ranks among the most abundant materials in the space between stars. Giant molecular clouds, those sprawling birthplaces of stars, abound with water vapor. The outer regions of our solar system, which the Sumerians linked to the original watery chaos, are truly ruled by water ice now. Think about what people in the ancient world understood regarding the Milky Way. The Sumerians and Babylonians carefully watched and documented it, calling it a luminous stream arching across the heavens. Various societies have viewed the Milky Way in diverse ways. Some saw it as a pathway, others as milk spilling from a goddess's breast, or even a connector between realms. Yet the Sumerian idea of it as a heavenly waterway stands out, since contemporary astronomy shows that the Milky Way galaxy actually moves in a flowing manner. It spins around its core. Our solar system circles the galactic hub at roughly 220 kilometers per second, needing 225 to 250 million years for a full loop. The whole galaxy forms an enormous swirling stream of stars, gases, and debris. Remarkably, the immense size that the ancients sensed for the Milky Way aligns pretty well with our current estimates in relative terms. They portrayed it as endlessly huge, stretching past any possible reckoning. Today's science puts the Milky Way at holding 100 billion to 400 billion stars across a disk about 100,000 light-years wide. Its actual magnitude truly defies easy human grasp. This leads to a larger puzzle relevant to both the Sumerians and the Dogon. When old civilizations detail cosmic truths they seemingly couldn't have accessed, we face just a handful of potential answers. They might have perceived these via methods lost to us, or figured them out through logic we've yet to fully trace, or perhaps gained the details from a wiser external influence, or it could all boil down to chance, error, or later influences. Conventional science naturally leans toward that final option. It's the most cautious, the least bold, demanding the smallest leaps. However, as these instances build up, as the flukes multiply, and as the precision of that ancient insight sharpens, the safe bet begins to buckle from the pressure. Let's explore the insights on precession more closely, as this is where the proof grows strongest and hardest to brush off. The precession of the equinoxes, as we noted earlier, forms a loop of about 25,772 years. Spotting it demands tracking star locations across at least several hundred years. Pinning it down precisely calls for data from thousands of years. Weaving it into myths and buildings demands not only grasping the pattern, but choosing to pass it on intentionally to those who come after. The Sumerians constructed their shrines with celestial alignments in mind. Those ziggurats, the tiered pyramid-like edifices that towered over Sumerian settlements, were set to the main compass points and frequently aimed at particular star risings. The Enki Temple in Eridu, among the earliest sacred spots in Mesopotamia, displays signs of stellar positioning from the 5th millennium BCE, but mere alignment to the compass isn't enough to confirm precessional awareness. What hints at it strongly is how the Sumerians segmented time and space with figures that tied directly to precession multiples. Their sexagesimal counting method yields precisely the values for computing precession. A circle of 360 degrees, the 12 zodiac signs covering 30 degrees each, 2,160 years for each astrological era, 72 years per degree of precessional movement, and 25,920 years for the complete turn, which nearly matches the current figure and equals 360 times 72. Such values aren't random. They link up mathematically, all tying back to the precessional rhythm. The Sumerians didn't create the base 60 setup just for precession, but the reality that their numerical framework fits so seamlessly for capturing precessional calculations is either a stunning fluke or a sign that it was crafted with precession as a key consideration. Take the Sumerian notion of the great year as well. The Sumerians, like many early societies, spoke of recurring eras, extended epochs that cycle through set sequences. The Sumerian king list chronicles pre-flood rulers with reigns stretching tens of thousands of years, summing to 432,000 years, a figure we've already flagged as precession linked. The Hindu Yuga framework, which certain experts trace to Mesopotamian roots or a shared origin in timelines, relies on identical foundational numbers. A Kali Yuga lasts 432,000 years. A Dwapara Yuga runs 864,000 years, or twice 432,000. A Treta Yuga spans 1,296,000 years, 3 times 432,000. A Satya Yuga covers 1,728,000 years, 4 times 432,000. The entire cycle of a Maha Yuga spans 4,320,000 years. These figures aren't just arbitrary giants. They're methodical multiples of precessional cycles, showing up in civilizations that, according to standard history, evolved separately. That leaves us with 2 possibilities. Either these societies each stumbled upon identical numerical frameworks by sheer chance, an improbability on an epic scale, or they drew from a shared well of astronomical insight that long predated them. Archaeoastronomical clues go further than mere digits, reaching into built environments. Take the Great Sphinx at Giza in Egypt. It stares straight east, aligned with the sunrise on the vernal equinox. Today, that lines up with Virgo during the spring equinox. Yet precession shifts the stars, so around 10,500 years ago, the equinox dawn would have fallen in Leo, the lion. Scholars like Robert Bauval and Graham Hancock propose that the Sphinx's leonine form was crafted to symbolize the Leo era, pushing its origins back to roughly 10,500 BCE, far earlier than Orthodox Egyptology's timeline for its building. This idea sparks fierce controversy. Conventional experts link the Sphinx to Pharaoh Khafre circa 2500 BCE. However, geologist Robert Schoch from Boston University points to erosion on the enclosure walls that matches heavy, sustained rainfall, implying the structure dates to a wetter Sahara phase, possibly before 5000 BCE. No need to resolve the Sphinx controversy right now. The key point for us is the recurring theme. Spanning societies, lands, and eras, we encounter signs of advanced celestial understanding, especially awareness of precession woven into myths, structures, and numeric frameworks. Time and again, those who held this wisdom didn't claim it from their own stargazing, but from teachings by extraterrestrial entities. The Sumerians pointed to Enki and the Anunnaki. The Dogon spoke of the Nomo, amphibian visitors from the Sirius system. Egyptians honored Thoth, the ibis-headed deity of intellect and lore. Greeks revered Prometheus, who snatched fire, a stand-in for enlightenment from the divine realm, and bestowed it on mortals. The motif repeats. Profound insights enter from beyond humanity. They're bestowed, not unearthed. Such gifts revolutionized societies, sparking advances in math, stargazing, farming, script, and healing. And the givers, portrayed as decidedly not human. To clarify exactly what we mean and don't, we're not claiming extraterrestrials erected the pyramids or that early humans lacked the smarts to innovate solo. Rather, the ancients themselves insisted their expertise originated externally. The astronomical prowess they displayed, especially, poses challenges for explanation via pure, unassisted human effort. No one's doubting ancient ingenuity. They shone brightly. Consider Babylonian celestial math, Egyptian structural mastery, or Polynesian wayfinding feats. All highlight remarkable human potential. The real puzzle. Could the precise stellar details in their deepest lore have built up through routine observation in the limited time they had, or does it hint at an undiscovered knowledge origin? Contemporary astronomy celebrates its breakthroughs. William Herschel's 1781 sighting of Uranus marked a win for telescope tech. Johann Gall's 1846 verification of Neptune, guided by Urbain Le Verrier's calculations, validated Newtonian physics. Clyde Tombaugh's 1930 detection of Pluto made global headlines. Yet, let's pause and scrutinize these milestones more closely. The archives reveal overlooked nuances. Herschel first mistook Uranus for a comet in 1781. It required months of scrutiny and computations from fellow stargazers to establish it as a planet, tracing a nearly round path well past Saturn. The discovery of Uranus wasn't the first sighting of the planet. In fact, it had been noted and documented on at least 17 occasions prior to Herschel's official identification, dating back to John Flamsteed in 1690 and perhaps even further. Astronomers had recorded it as a dim star in their catalogs, then overlooked it entirely since no one anticipated a planet occupying that space. This oversight carries real weight. Under ideal viewing conditions, Uranus reaches a magnitude of about 5.7, making it just barely detectable without a telescope. Yet, within the Western astronomical framework, no one recognized it as a planet until 1781. Largely because the prevailing solar system framework accounted for just 6 planets, leaving observers unprepared for a 7th. The missed opportunity with Uranus stemmed not from shortcomings in seeing, but from preconceived notions. Observers spotted it, but dismissed it as a weak star, as their cosmic framework excluded the chance of an additional world. Had the Sumerians possessed a framework that encompassed objects past Saturn, they could have sidestepped this issue. They would have directed their gaze accordingly. Although Uranus hovers at the limit of unaided visibility, an expert watcher, armed with precise knowledge of its location and a predictive mathematical framework, could have distinguished it from surrounding stars by monitoring its gradual shift across the sky over extended periods. This doesn't explain why they would search in the first place, but it highlights that the barrier to spotting Uranus went beyond mere sight. It was rooted in mindset, and the Sumerians might have lacked that mental hurdle. Neptune presents a far more challenging case. With a magnitude of 7.8, it's utterly beyond naked eye detection. No degree of expertise or meticulous scrutiny could reveal Neptune without telescopic assistance. Nevertheless, Layard deduced its presence and location through pure mathematics, never having laid eyes on it, drawing solely from irregularities in Uranus's path. He forwarded his computations to Johann Galle at the Berlin Observatory, where Galle pinpointed Neptune just 1 degree from the forecasted spot on his initial observation night. Layard's work proved that direct visibility isn't required to confirm a planet's reality. With detailed data on visible planets and robust mathematical methods, one can deduce an invisible body's existence from its gravitational influence on those that are observable. This mirrors the approach Bessel used in 1844 to predict Sirius B, nearly 20 years prior to its actual sighting. Might the Sumerians have employed a comparable technique? If they commanded the mathematical prowess to forecast planetary paths via techniques akin to early integral calculus, as the 2016 Ocean Driver study verified for Babylonian Jupiter monitoring, they could have had the means to identify gravitational disturbances too. Not with Leverrier's exactitude, to be sure, but possibly with sufficient acuity to infer large masses lurking beyond the seen planets. Such ideas remain conjectural, and we must note the absence of any single tablet detailing perturbation computations. Still, evidence points to Mesopotamian astronomers wielding far greater mathematical skill than once thought, paired with a world view incorporating entities beyond direct sight. That combination raises intriguing dilemmas. The revelation of the asteroid belt introduces yet another layer. Giuseppe Piazzi's 1801 detection of Ceres was deliberate. He was hunting for a planet. The Titius-Bode law, which links planetary distances from the Sun via a mathematical pattern, indicated a world should occupy the void between Mars and Jupiter. Piazzi's find of Ceres aligned almost perfectly with that projected range, appearing as a major success. However, Ceres proved far too diminutive for a full-fledged planet, and later finds like Pallas, Juno, and Vesta in the vicinity showed not a solitary body, but a vast ring of countless minor rocky fragments. As noted before, today's view attributes this to Jupiter's pull disrupting the zone's material from forming a cohesive planet. Yet, for nearly 100 years, an alternative theory held sway. A planet had formed there only to shatter, scattering asteroids as remnants. This idea never faced outright refutation. It simply waned as the disruption model built stronger backing. The Enuma Elisha's account of Tiamat's dismemberment, with her pieces strewn through the heavens, fits the shattering theory more neatly than the formation blockage one. Whether this stems from true ancient insight or mere mythic happenstance, the Sumerians depicted a cataclysmic event precisely where we observe scattered debris in the solar system. In 2005, the NICE model referenced earlier offered fresh insights into the asteroid belt's origins. Under the NICE framework, Jupiter and Saturn's resonance-driven migration would have drastically disturbed the protoplanetary disk material between Mars and Jupiter, flinging large portions both outward and inward. While this doesn't equate to a full planetary demolition, it still represents a chaotic upheaval of matter in that precise region, with Jupiter playing the central role in the disturbance, echoing yet again the account in the Enuma Elish. Now, let's explore another point where ancient insights align with contemporary findings, the ongoing debate over the solar system's planet tally. At first glance, this appears simple, yet it's surprisingly divisive. The 2006 International Astronomical Union ruling that downgraded Pluto to dwarf planet status dropped the recognized count from 9 to 8, sparking heated debate. Numerous planetary experts continue to view Pluto as a true planet. On top of that, spotting sizable trans-Neptunian objects like Eris, which outweighs Pluto, has forced us to rethink either the system's planetary abundance or the criteria for planet status. Fast forward to 2016, when Caltech's Konstantin Bedygin and Mike Brown shared data supporting Planet 9, an inferred world about 10 times Earth's mass, circling far past Neptune. Their case relies on indirect clues, namely the unusual grouping of distant trans-Neptunian orbits apparently tugged by some hidden heavyweight. To date, Planet 9 remains unseen directly, though various separate studies have bolstered the orbital math backing its presence. Should it turn out real, we'd restore the count to 9 planets. Factor in notable dwarf planets such as Pluto, Haumea, Makemake, and Eris as key players, and the roster of prominent solar system objects begins to mirror the figures shown in select ancient Mesopotamian artifacts and writings. I'm not framing this as definitive evidence, merely noting that our grasp of the solar system's makeup is still shifting, and the Mesopotamian worldview from antiquity might not have been as off-base as mid-20th century stargazers believed. Shifting to the larger picture, let's weigh the full scope of these findings combined. The Sumerians outlined a solar system boasting extra bodies beyond what's visible unaided. Their numerical and mythic frameworks wove in precession cycles. They employed predictive astronomical techniques not revived in Europe until the 14th through 17th centuries. Accounts of planetary traits align with what we observe today. The Dogon held precise details on an unseen stellar partner. Egyptian structures boast alignments encoding exact star placements with remarkable accuracy. Precession motifs crop up in myths worldwide. Sure, you could brush off each piece alone. Maybe the solar layout was just luck. The numbers stemmed from their base 60 math for unrelated motives. The Dogon picked up serious B info from outsiders. The Egyptian sites aligned by chance. The math techniques arose separately elsewhere. But stack them up, and the sheer volume defies simple rejection. It's not a single fluke, but a barrage of them, all converging on one idea: that astronomy's backstory runs far deeper and more intricate than the standard story admits. That standard tale portrays knowledge building slowly, from basic sun-moon watches to unaided planet-star views, peaking with the Copernican shift and telescope era. There, ancient contributions come off as quaint starters, soon outpaced by rigorous science. What we've reviewed here points to an alternative. Advanced astronomy thrived in the distant past, possibly predating recorded societies. This wisdom spread in diverse guises, often diluted through eras and peoples. In numerous instances, today's telescope-driven science has validated ancient records rather than unveiling wholly fresh truths. This isn't to downplay modern astronomy or swap scopes for tablets. Our tools uncover specifics beyond ancient reach, like stellar chemistry, black hole frameworks, or the Big Bang's lingering microwave glow. Contemporary science offers tools for validation and exactness that ancient customs simply don't possess. However, this realization suggests we may need to revise the timeline of astronomical insights, not to elevate ancient peoples over today's science, but to fairly recognize the sophistication and reliability of those old ways, and to genuinely explore the origins of that early wisdom. The Sumerians claimed Enki bestowed it upon them. The Dogon asserted the Nomo delivered it. The Egyptians believed Thoth disclosed it. These accounts are mythical in nature, possibly symbolic rather than factual, yet they follow a similar pattern. Wisdom arriving from beyond everyday human society, wisdom that reshaped societies, wisdom focused on astronomy, on mathematics, on the cosmos's form and movements. Suppose these stories hold more than metaphor. Suppose they encode, through symbolic tales, a true recollection of knowledge shared by an unidentified origin. That origin might be a vanished culture, an idea growing more credible as we uncover the intricacies of early human groups. It might involve extraterrestrial influence, a notion that seems outlandish, but one the old writings openly depict. Or it could be altogether different, perhaps a method of gaining insight we haven't grasped yet. The straightforward truth is, we remain uncertain. None of these ideas can be confirmed with what we have right now. Yet we must admit the usual view, slow progress via bare-eyed watching, fails to explain everything. The traditional account overlooks key elements that could clarify how the Sumerians grasped their insights, how the Dogon acquired theirs, how precessional values became woven into global myths. Hunting for that overlooked factor stands as one of today's most captivating scholarly enigmas. It links digs and stargazing, legends and equations, old chronicles and cutting-edge research. Scholars across these areas are methodically advancing it, each adding fragments to a riddle too vast for one field alone. But imagine if these weren't original findings at all. Imagine if they were recoveries. Imagine if today's stargazers, with their scopes and formulas, are gradually validating truths already inscribed on clay fragments from forgotten urban remains. The concept feels bold, but as facts accumulate, shard by shard, inscription by inscription, figure by figure, it becomes harder to ignore completely. Look at the sequence. The Sumerians outlined a sun system boasting extra orbs beyond the 5 naked-eye worlds. Later, astronomers verified more planets. The Sumerians noted a ring of rubble between Mars and Jupiter. Astronomers located the asteroid belt. The Sumerians wove precessional figures into their calculations. Astronomers later verified the equinox's shift and its precise measures. The Dogon detailed traits of Sirius B. Astronomers substantiated those traits. Time and again, the ancient assertion precedes the modern validation by decades, ages, or even epochs. This doesn't confirm every old sky claim as true. It doesn't validate the Anunnaki's existence, the Nomo's journey from Sirius, or Enki as a tangible figure dispensing wisdom slabs. Instead, it's a recurring motif warranting thorough, disciplined study. A motif implying the tale of humanity's sky lore is richer, more intricate, and more enigmatic than schoolbooks typically portray. The tablets of fate, the Mi Enki supposedly granted, might be legend, but the insights they're said to hold prove tangible. The star facts in Sumerian writings hold up. The precessional figures check out. Their sun system depiction outshines Europe's efforts for the following 3 millennia. Thus, we circle back to the core query, leaving it unresolved yet insistent in the shadows. How did they know? The solution might hide in untouched dig site soil, in untranslated slabs, in overlooked customs, or it might rest in an option science has shied from. That what we deem a breakthrough can sometimes be a recall, that the forefront of sky science may echo the afterglow of something far more ancient. One vision recurs when delving into these old lore, a Sumerian writer in a temple, etching a reed tip into damp clay by flickering light, noting digits and celestial spots that await rediscovery for 4 more millennia. What thoughts ran through that scribe's mind? Did they jot down first-hand sightings, gained from countless nights atop the temple roof, relying solely on sharp eyesight and rigorous math skills? Or perhaps they were merely replicating ancient scrolls, safeguarding wisdom that felt timeless even back then? Maybe they were simply documenting lore passed down from a revered authority they deemed superior to their own understanding. The clay tablets offer no clues on that front. They simply deliver the raw figures. And when we scrutinize those figures with an open mind, they spark inquiries that challenge the completeness of our prevailing historical frameworks. According to Sumerian lore, prior to the deluge, the massive flood, echoed in myths from cultures across the globe, existed an antediluvian society brimming with profound wisdom and antiquity. A realm, as detailed in the Sumerian king list, where monarchs ruled for millennia, where insights streamed directly from deities to mortals, where the sacred me were instituted. Then came the cataclysmic waters, and as they ebbed, humankind faced the task of reconstruction, yet not entirely anew. Tradition holds that certain individuals safeguarded vital lore, enshrining it in vessels, concealing it within structures' bases, or weaving it into enduring tales meant to outlast disasters. Contemporary geology verifies that enormous inundations struck around the close of the last ice age, about 11,600 years past, as enormous glaciers thawed and oceans surged upward by more than 120 meters. Huge swaths of once livable terrain submerged. In certain zones, shorelines pulled back by hundreds of kilometers. Any settlements on those vulnerable shores would have vanished, their traces now entombed under thick layers of silt on the seafloor. Underwater archaeology is still emerging, and the vast continental shelves go mostly unprobed. Our grasp of Mars's terrain outstrips what we know of Earth's submerged seabeds. The likelihood of major relic sites resting below the surface isn't mere conjecture, it's practically guaranteed. Considering the expanse of land swallowed by ascending waters, might an advanced pre-flood society have thrived, one capable of the celestial expertise embedded in Sumerian writings? Conventional archaeology dismisses it, citing a lack of tangible proof. Yet lacking proof doesn't prove non-existence, particularly when probable sites lurk submerged, unexamined, or a combination thereof. Still, another domain where this venerable star lore meets today's findings warrants close scrutiny: the very concept of time, how the ancients tracked it, segmented it, and what their approaches disclose about their intellectual sophistication. The Sumerians didn't merely devise the sexagesimal system, they erected a comprehensive framework for chronology atop it. 60 seconds per minute, 60 minutes per hour. These aren't random splits. They've endured through every ensuing empire, every mathematical upheaval, every calendar overhaul because they're effective. 60 factors neatly into 2, 3, 4, 5, 6, 10, 12, 15, 20, and 30. It's among the most adaptable figures for partitioning, explaining its selection for time and angular measurements. Consider the implications of the Sumerians opting for this specific base. They might have stuck with decimal, aligned with our 10 digits. The Egyptians did. The Chinese did. Innumerable societies leaned decimal for its instinctive appeal, but the Sumerians intentionally embraced a more intricate setup for its superior computational perks especially suited to celestial studies. In sexagesimal, precessional values emerge with striking clarity. The complete precession cycle, roughly 25,920 years, renders as 432, simply 7 times 60 plus 12. Each precessional degree spans 72 years, or 1 times 60 plus 12. The 360-degree circle equates to precisely 6 times 60, The zodiac's 12 constellations fit the 360 degrees perfectly at 30 degrees apiece, and 30 is exactly 60 halved. These alignments aren't happenstance. They're direct outcomes of adopting base 60 as the core numeral framework, and they all tie back to precessional celestial mechanics. It seems the numerical framework was crafted to streamline precession computations, prompting us to wonder, did the tracking of precession inspire the adoption of base 60 from the outset? If that's the case, then the Sumerians, or those who imparted their mathematical knowledge, must have grasped precession long before finalizing their counting method, extending this awareness deeper into antiquity than the oldest surviving records suggest. The Sumerian calendar further showcases their advanced grasp of the stars. It kicked off at the vernal equinox, that exact instant when the sun passes over the celestial equator, moving northward. Pinpointing the equinox's true timing demands meticulous sky watching. It's not merely noting the sun's spot on the horizon, it involves monitoring its declination, the angle from the celestial equator, with the accuracy needed to spot the crossover. The Sumerians juggled two calendars at once. One followed the moon, lasting about 354 days, from 12 29.5-day months. The other tracked the sun, spanning roughly 365.25 days tied to seasonal shifts. Bridging these mismatched rhythms meant adding occasional extra months to the lunar schedule, a practice the Sumerians managed via guidelines that synced their calendar to both moon phases and sun-driven seasons across extended timelines. The 19-year Metonic cycle, credited to the Greek astronomer Meton, who outlined it circa 432 BCE, shows that 19 solar years nearly match 235 lunar months. Thus, after 19 years, lunar phases realign with similar calendar days. The Babylonians applied this cycle for calendar adjustments, with the supporting observations tracing well into Sumerian times. From our vantage, the Metonic cycle stands out because spotting it demands a minimum of 19 years of data, and verifying it calls for several repeats, realistically 57 to 76 years of diligent logging. That's feasible over a handful of generations, in contrast to precession's demand for thousands of years. So the Metonic cycle offers a milder benchmark. Could we verify the Sumerians' ability to sustain long-term astronomical monitoring? Absolutely. Their cylindrical records leave no doubt. If they managed observations over decades, it opens the door to whether they could handle those lasting centuries or even millennia. And textual clues hint at this possibility. The Sumerian king list chronicles rulers going back millennia before the flood, with reign durations that are clearly symbolic yet, per certain scholars, embed astronomical timelines. Interpreting those pre-flood reigns as veiled celestial metrics rather than straight history uncovers links to planetary paths, eclipse patterns, and precession. Though debated, the numerical ties hold up under scrutiny. The sum of 432,000 years for the antediluvian rains ties directly to precession. Specific rain spans include multiples of established planetary cycles. Intentional design or happenstance hinges on one's beliefs, but the figures stand firm. Consider, too, a modern planetary theory unveiled not long ago that unexpectedly echoes Sumerian myths. The NICE model, named for the French city of its origin, posits that the solar system's outer giants didn't always orbit as they do now. It suggests Jupiter, Saturn, Uranus, and Neptune started in a tighter setup before drifting outward over hundreds of millions of years, their pulls sparking orbital chaos that flung minor objects across the system. This outward trek, dated to around 4 billion years past, triggered the late heavy bombardment in the inner solar system, a barrage of asteroid and comet strikes that pocked the moon, Mars, Mercury, and Earth. Lunar craters like Imbrium and Oriental bear witness to this era. Viewed through an astronomical lens, the Enuma Elish narrates a strikingly parallel event. An era of heavenly upheaval, where bodies reposition, clash, and hurl fragments. Marduk, linked to Jupiter, drives this cosmic shuffle. Much like Jupiter's key role in the Nice model, Marduk's vanquishing of Tiamat and the dispersal of her remains mirrors the shattering of protoplanetary disks and their spread through the solar system. It's possible that this resemblance is merely by chance. Many creation stories feature battles among celestial forces and subsequent rearrangements of the heavens. Yet the particulars here stand out. Jupiter acting as the key disruptor, a planetary body shattered into fragments that spread out as a scattered disk, and a consequent reshuffling of orbits in the solar system. Such elements go beyond typical mythic tropes. They represent detailed assertions about the solar system's architecture and origins, insights that contemporary planetary research has corroborated separately via simulations on computers and examinations of meteorite compositions. The ancient Egyptians contribute yet another dimension to this narrative. Although their celestial expertise was conveyed in ways distinct from Sumerian lore, it reveals comparable levels of refinement that surpass mere naked eye watching. The orientation of the Great Pyramid at Giza offers the most renowned instance. Its foundation aligns with true north to within about 3/60 of a degree. Such exactness is astonishing regardless of the period, demanding more than vigilant tracking of the North Star. It called for grasping the distinction between magnetic and true north, adjustments for atmospheric bending of light close to the horizon, and either exceptionally precise land measurement or celestial tracking techniques that experts today still puzzle over reconstructing. The internal passages of the Great Pyramid, once thought to be mere air channels, have proven to target particular stars on particular historical dates. For example, the southern passage from the King's Room aligned with Orion's belt circa 2500 BCE. The one from the Queen's Room targeted Sirius around that same period. The northern passage from the King's Room aimed at Thuban, the era's pole star in Draco, while the Queen's northern passage pointed to Kochab in Ursa Minor. These orientations aren't rough estimates. They're so exact that they've enabled astronomical dating of the pyramid's building, and those dates align with the roughly 2560 BCE timeline established through digs and artifacts. From the viewpoint of precession, though, this gets fascinating. Precession shifts these alignments to a narrow window, a few hundred years off either way, and the passages would target other stars or blank areas of sky. The pyramid's architects either nailed this by sheer fortune, unlikely considering all four passages hit meaningful stellar targets, or they commanded exact foreknowledge of stellar locations during construction. Achieving that would mean either spot-on real-time sightings or possession of star charts capable of forecasting positions across various times. Historical records firmly link Egyptian and Mesopotamian sky-watching practices. Both societies monitored identical planets, employed alike stellar timetables, and timed sacred ceremonies to shared heavenly occurrences. Egypt's Isis linked to Sirius, much like Sumerian rites followed Sirius's first pre-dawn appearance. Each culture split the day into 24 hours, 12 for day, 12 for night. They both relied on deacons, those chosen stars whose appearances and disappearances segmented the night like a cosmic timepiece. The Dendera zodiac, that celebrated carved panel overhead in Egypt's Hathor temple at Dendera, displays the full dozen zodiac signs in their blended Greek-Egyptian style, alongside renderings of the 5 planets visible to the eye. Yet the Dendera zodiac's real intrigue lies in claims by certain experts that it embeds details on precession. Some constellation placements against the solstice axis fail to fit the skies of the temple's Ptolemaic building era. Rather, they evoke much older heavenly arrangements, suggesting the zodiac aimed to depict precession's effects, how the stars shift across vast timescales. This view sparks debate, with others viewing it as a simple snapshot of the contemporary firmament. Even so, absent direct precession coding, it underscores the identical celestial prowess evident in Mesopotamian records: meticulous mapping of wandering stars, orderly grouping into asterisms, monitoring of seasonal turning points, and predictive math models. Across Sumerian, Babylonian, and Egyptian legacies, the evidence converges on a profound, precise astronomical heritage that predated the oldest extant writings, heritage that, in numerous tested instances, foreshadowed scientific breakthroughs by thousands of years, and which these societies invariably traced back to origins beyond humanity itself. The Sumerians attributed it to Enki and the Abgalu. The Egyptians attributed this wisdom to Thoth, the deity they portrayed as the one who gauged the expanse of the skies and tallied the celestial bodies. The Dogon ascribed it to the Nomo. Varied titles, diverse legendary contexts, yet the core assertion remains identical. Humanity didn't evolve this insight through steady human effort. Instead, it was bestowed upon us by entities originating from beyond our world. What endures is the insight preserved in enduring forms, etched into clay tablets, encoded in numerical patterns, embedded in the designs of ancient timekeeping systems, and aligned within the layouts of monumental structures. This is tangible, confirmable information that, in numerous instances, surpass the precision of subsequent societies deemed more sophisticated, outpacing them by thousands of years. The Sumerians lacked telescopes. They had no access to radio telescopes, orbital spacecraft, or methods for spectral examination. Nevertheless, their depiction of the universe, in its overarching framework and numerous precise elements, aligns closely with revelations from those very technologies. This leaves us with two possibilities. Either they made the most improbable lucky hunches in all of history, or they drew from sources of data that our conventional timelines fail to explain. Enki, master of seas and wisdom, guardian and sharer of the me, the divine figure who cared deeply for humankind by alerting them to the impending deluge. Perhaps he's merely a figure of lore. Yet the lore tied to him is far from fanciful. It's rooted in astronomy, grounded in mathematics, and open to empirical proof. Increasingly, such proof has materialized. As you rest in the shadows this evening, ponder the implications of a modest clay slab inscribed in a Sumerian settlement 4 millennia past, holding precise details on the solar system's architecture, the makeup of remote stellar bodies, and the gradual axial tilt of our planet across vast epochs spanning tens of thousands of years. Consider the significance of a rural West African village articulating traits of a white dwarf that European stargazers required their era's mightiest optics to detect. Reflect on how identical figures 72, 360, 260, 25,920, 432,000 surface in the legends of societies divided by vast seas and endless ages, groups presumed isolated from one another, all weaving in the identical cosmic event. And contemplate the weight of ancient voices unanimously declaring this lore wasn't unearthed through toil, but handed down from otherworldly visitors. We needn't endorse every facet of ancient astronaut hypotheses. We aren't obligated to interpret every etched cylinder as a spacecraft blueprint or every stepped pyramid as a beacon site. Instead, we ought to approach these ancient writings with genuine respect for their intent. Scrutinize the stellar insights they hold using today's exacting standards and confront the findings candidly. Those findings challenge orthodox narratives, not by validating any single rival idea, but by revealing that early civilizations grasped concepts beyond their supposed reach, rendering our typical accounts of their origins ever more inadequate. Those clay artifacts persist in global museum vaults. Plenty sit untranslated. Some bear irreparable scars. Others gather dust in archives, pending review by strained academics with scant resources. The complete breadth of Sumerian celestial lore remains uncatalogued, much less thoroughly dissected. What revelations await full exploration? Drawing from historical patterns, we'll likely uncover further accuracies in Sumerian records, additional cosmic specifics that no one from 4,000 years ago should have fathomed, yet evidently did. Fresh inquiries that strain against our present frameworks. And more indications that contemporary stargazing, for all its triumphs, from orbiting observatories and ripple-sensing instruments to planetary wanderers, doesn't solely forge ahead into uncharted realms. At times, it retraces ancient roots. It follows trails charted in humble script long before Greece's inaugural thinkers emerged, before Rome's stones were laid, before our modern scripts took shape. The Sumerians committed it to clay. We document it in peer-reviewed journals. The format has evolved. The substance often stands unchanged. From where do you tune in this night? Dawn in Tokyo, midday in Melbourne, drizzle over London. No matter your spot, the vault overhead mirrors what the Sumerians observed. The constellations they listed shine down still. The worlds they monitored trace the orbits they outlined. The equinox's grand cycle continues its languid spin, shifting 1 degree each 72 years. Exactly as those old records foretold, rest easy, the heavens await your return. They've endured since clay yielded to the stylus, since urban hearths first flickered, since the earliest etchings scarred the earth, and the enigmas they stir concerning ancient insights and their origins, about whether our breakthroughs are truly novel, linger just as enduringly. Those inquiries linger just as persistently as the tablets do, poised for a diligent reader to decipher their deeper truths. The celestial expanse of antiquity holds its secrets with infinite calm, narrating its tale across billions of years. The Sumerians were pioneers in committing that narrative to writing. We continue to lag behind their inscriptions. Nestled in the divide between their insights and our verified findings rests a profound enigma of humanity's past, one etched in clay, in the glow of stars, in the gradual, timeless tilt of our planet's axis over epochs. All of it survives, embedded in those tablets, shrouded in the remnants of forgotten archives. The reality of that wisdom is beyond doubt. Contemporary astronomy has validated it. What truly puzzles us is its origin. For the moment, that enigma stretches as wide, boundless, and brimming with potential as the starry heavens themselves. The Sumerians gazed upward and beheld the same wonders we do. They articulated the phenomena we've quantified. They grasped concepts we're only now unraveling, and they attributed it to gifts from the rulers of sky and soil, from Enki and the Anunnaki, from entities arriving from realms outside our own, who inscribed a legacy of universal wisdom into clay, a record enduring through the ebb and flow of every era since. Regardless of whether their account resonates with you, the wisdom stands firm. it's embedded in the tablets, in the precise figures, in the orientations of sacred sites, the designs of timekeeping systems, and the shared legends across global traditions. Each year, as astronomers unveil fresh revelations, with our scopes probing farther into the void and our explorers touching remote planets, we repeatedly discover that the ancients preceded us, not through gadgets or tools we recognize, but via insights captured on clay, safeguarded across ages, lingering for us to finally comprehend. Perhaps the true wonder lies not in their awareness, but in their foresight that we would one day share it. They etched it onto clay, their toughest means of preservation, and concealed it within the bases of enduring sanctuaries, as though they foresaw that millennia hence excavators would unearth those relics, master their script, and at last pose the pertinent inquiries. Those inquiries don't challenge the ancients' sophistication. They weren't rudimentary, nor do they undermine current science. It's sound. Instead, they probe the chasm between the ancients' erudition and the limits we presume they faced. They explore the chance that our species' timeline is far richer, more profound, and intricately linked than we've imagined. They ponder what other revelations those tablets hold, awaiting translation, and they question if the arc of human understanding represents a gradual buildup from obscurity or a fragmentary reclamation of an ancient heritage teetering on extinction. The clay persists, the tales persist, and with them, a vital essence of the ancients' cosmic comprehension persists as well. Before we ease into slumber, let's reflect on one final element tying together our evening's reflections, arguably the deepest connection of all, the matter of magnitude. The Sumerians grasped the cosmos's immensity in ways later societies largely overlooked. Their numeracy, stellar models, and mythic accounts all evoke a realm of inconceivable vastness. Far from the snug, enclosed universe of medieval Europe's crystalline orbs with Earth at its heart, or the confined vault of stars viewed as lanterns on a heavenly canopy by many early farming cultures, the Sumerians portrayed a domain of dizzying expanses, colossal durations, and rhythms that eclipse mortal lifespans. The precession cycle, spanning about 26,000 years, compresses all documented human chronicles into a fleeting moment. The antediluvian eras in the Sumerian king list, aggregating 432,000 years, hint at a temporal scope no isolated society could fathom. The Hindu Yuga framework, echoing Mesopotamian timelines, extends into millions and billions of years. Today's science affirms these grand chronologies. Earth dates to 4.5 billion years ago, life to around 3.8 billion years, intricate multicellular organisms to about 600 million years back, anatomically modern humans to roughly 300,000 years ago, and behavioral modernity with its art, speech, advanced implements, and abstract reasoning to some 70,000 to 100,000 years prior. The Sumerians, with their expansive timelines and recurring perspective on existence, viewed time in ways that aligned more closely with contemporary cosmology than with the straight-line, human-focused timeline that shaped Western thinking across those many centuries in between. Bishop Ussher's well-known 1650 estimate placing the world's creation at 4004 BCE would have seemed ridiculously narrow to a Sumerian stargazer. Their system spanned at least hundreds of thousands of years, and their repeating pattern implied the universe had endured numerous cycles, multiple eras, births, and collapses. This looping outlook echoes intriguingly with today's cosmological ideas. Concepts like a universe that repeatedly expands and contracts have gained traction among scientists, such as Roger Penrose, whose conformal cyclic cosmology posits that the Big Bang could mark the start of merely one loop in an endless chain. Paul Steinhardt and Neil Turok have advanced the ekpyrotic model, where our cosmos arises from clashes between higher dimensional brains, potentially one of countless such events stretching time eternally in both directions. Though these are frontier ideas, unverified for now, they echo a core Sumerian idea. The universe might lack a solitary start and finish. Time could loop rather than march forward. Our surroundings might represent just a segment of a grander, more enduring cycle. The Sumerians wove this outlook into their myths, their numerical systems, their temple designs, and the patterns of their ceremonies. Today's physicists reach comparable insights via distinct paths: general relativity, quantum mechanics, and scans of the cosmic microwave background. The paths diverge. The outcomes strikingly converge. One key distinction in the Sumerian pursuit of understanding sets it apart from the modern Western method, and that gap could clarify why their star-gazing expertise soared while their practical inventions, from what we know, lagged behind. In our science, insight leads straight to use. We uncover a law and craft a device. We grasp a power and tame it. The shift from revelation to implementation feels instinctive and unavoidable. Grasp electricity, and circuits follow. Master orbits, and rockets emerge. The Sumerians seem to have handled wisdom otherwise. For them, celestial lore was holy. It fell under divine domain. It flowed via the me, the godly edicts, and its main aim wasn't invention, but grasping the universe's order. Tracking planetary paths mattered not chiefly for crafting tools, but for unveiling truth's architecture. It linked mortal life to heavenly harmony. It shaped ceremonies, foretellings, and awareness of one's role in the cosmic engine. This reverent stance toward star knowledge yields a notable outcome. The Sumerians may have held deeper conceptual grasp than they ever turned into lasting artifacts. They could have discerned cosmic patterns without deploying them to produce tangible traces. A society can excel in sky lore without surging ahead in the inventions we'd anticipate. Insight and utility aren't the same, and societies can emphasize one above the other. That split might resolve an apparent riddle. How did the Sumerians grasp so much of the heavens, yet seemingly lack tools for direct views of far-off bodies? Perhaps they received that wisdom in a form they comprehended, but never put to work. Like a math scholar who memorizes a theorem, yet can't engineer the gadget it implies. The insight was genuine. The deployment wasn't the goal. And this leads to a closing thought. The Sumerians didn't merely document celestial facts, they documented their documentation. Their writings show striking self-reflection. They often highlight safeguarding old lore, transcribing from prior slabs, upholding archives that couldn't vanish. In Babylonian sky records, the colophons at tablet ends declare the copy's loyalty to an ancient source, sometimes detailing the chain of reproductions it survived. This habit of intentional archiving implies the Sumerians grasped a truth many later societies overlooked. Wisdom is vulnerable. Societies collapse. Archives go up in flames. Tongues fade into oblivion. To ensure that wisdom lasts, deliberate effort is required in safeguarding it. It must be inscribed on clay, the toughest material at hand. It demands meticulous replication across successive eras. It needs to be woven into enduring edifices that defy the ravages of time, into numerical systems independent of any particular tongue, into legendary motifs that linger in collective recall long after their initial settings vanish. The Sumerians accomplished every one of these feats, allowing their celestial insights to outlast the collapse of Sumer, the downfall of Akkad, the ruin of Babylon, the end of Assyria, the Islamic Golden Age, Europe's medieval shadows, and the era of colonialism, only to be unearthed anew by contemporary experts deciphering the ancient cuneiform and marveling increasingly at the treasures the old scribes had safeguarded. We stand as the very readers they composed for, not their fellow era's inhabitants who were already versed in such matters, nor the following cadre of copyists dutifully transcribing and handing down the tablets. Rather, us, the far-off descendants who would someday excavate those artifacts, master the writing, and at last grasp the inscribed truths. The clay persists, the narratives persist, and via them, a vital essence of the ancients' cosmic comprehension persists as well. Rest easy. The heavens adhere to their timeless rhythm, exactly as the Sumerians documented, and amid the sands of Mesopotamia, additional tablets lie in wait for discovery. Further wisdom awaits interpretation. Fresh inquiries await exploration. The eternal heavens overshadow us everywhere, brimming with untold mysteries.